Hey YouTubers, fellow aliens, we're going to do a little repair of a JX-10. So, look at this beast. It's my other beast. There's Ozzy. Fellow friend of all YouTubers alike. 15-year-old rescue. So this thing here, it's got a weak Midi output. Other than that, works okay, but needs a battery. So we're going to do that. Batteries it has is a CR2450. Make sure you buy a new one. We'll get into that. So we're going to take it apart. 3 screws on each side. 2 screws over here. And let's turn it off. It does work fine. Beautiful sounding. It's basically 2 JX-8 in a box, which is very cool. Let's take these off. So, there's some screws under here. So I'll get those off, I'll show you later. And this thing has a nice hinge on it. It's a beautiful, beautiful box to work on. So what I found out, I built this little Midi circuit. I'll attach these diagrams, but basically Midi is kind of like a current loop, sort of, kind of. And the output of the JX-10 isn't very strong. I measured it, it's like 3 volts peak to peak to a little opto isolator circuit. So this is what a Midi input on most of your keyboards look like. So here's your Midi coming in, goes into an opto. It's kind of like a current loop. See the diodes here? So the current comes in, turns on an opto isolator, and goes to the UART that's part of the Midi device. So I replicated that, this little beauty here, and measured the peak to peak Midi waveform. That's basically, it's just this opto isolator with a 6N137, which is 4 optos in a package. So I'm just using one of the 4. Pretty simple to replicate. Those are pinouts. Attached it to the Midi out of this device, of the JX-10. And you can see the JX-10, it uses an inverter. It's an LSO4. And when I did that, I noticed the output was only 3 volts peak to peak, and it should be like 5 volts peak to peak. So I have a wave station nearby. We'll be able to look at that. Make sure you get the right pinouts of the Midi signals. You want to get the pinout looking into the plug, not from the back, but from looking into it. And I found this on the Adreno Simple Midi Controller website. So I think I'll throw that link up there. And the other thing you're going to need, troubleshooting one of these beasties, is the Super JX-10 service notes. So these are available on the Internet Archive. All this stuff's available. It's nice. And you can see that it's implementation of the Midi in, out, and through. Thank God they have a through, because the new wave stations don't. Kind of pisses everybody off. Looks a lot like what the Adreno cards, or this is not the Adreno, but this is a Midi spec. So understanding all Midi spec type of thing. I'll post that link. But it looks a lot like the circuitries here in this Midi spec. So it's meeting the standard, but it's using LSO4, which is not an open collector, it's TTL device. And it's sinking some current through that opto. So in order to turn the opto on, here's your LSO4. You can look at this output basically is going here to this opto. So it's got to sink a fair amount of current to turn the opto on. It's like 10-20 milliamps. Depends on, we get 220 ohm blocking current limit resistor, and you have 5 volts there, so you can do the math. It's like 10 milliamps. So LSO4 is really not meant to sink that kind of current. It can, but it's not a good design. But you could use an open collector device, an LSO6, but Roland didn't. And if you would put that LSO6 in there, then you'd have to add some pull-ups on the first stage. So I don't feel like reworking the board, but I don't think that's too focused, is it? I'll attach images of that, but that's what's inside the Midi. It's an LSO4. So it's inside the JX-10, I mean. So we're going to get in there, figure out why I only have 3 volts. It's either transistor here, which is normally, as you can see over here, they just use a pull-up. Roland used a transistor, a pass transistor. So the transistor turns on as soon as power comes on, but if that transistor is weak or if it's got a problem, let's see if I can get this thing. Now it's not going to focus in on it, but you get the problem. It's either the transistor or it's the LSO4 inverter. So one of 2 parts. Pretty simple. We'll figure it out. And we're going to do a battery swap, and we're going to add a nice battery cage, so next time I don't have to desolder it. I don't think there's a battery cage in the JX-10. I haven't seen any videos on the JX-10 battery replacement, so and like I said, you need a 2450. Make sure you buy a new one. They only got like a 5-10 year shelf life. So that's what we're going to get into in a little bit. But I'll restart the video after I get the screws out, top open, take a look at that battery, and then we'll put some voltmeters on the circuits internally to see why we only have 3 volts and we need 5. So, out for now. Well, there she is. It's a beauty. Recommend a few things. It's like working on a car. Alright, so left side cover. I recommend you using these little containers. You know, you can get these from when you buy takeout, or you can just get some of these metal ones. Left side has 3 screws going in to the side. 2 screws, this is the gotcha screws, coming up from the bottom. Okay. I'll show you that. So, those 2 screws coming up from the bottom. One, it's a little dark over there. Let me get the light a little better. See that 2. So they come up, and then these 3 on the side. 3 holes. Ground the thing. Use an ESD strap. It's winter time here in Area 49. You don't want to zap all your circuitry. I mean, there's a lot going on inside there, as you can see. These two major boards, and then there's some other boards, and there's daughter boards, and there's the interface board that has the chips on it I have to get at. I found the battery, and there's the power supply. And I don't think the power supply caps are leaking. I think what this material is, you can see that down there, is the glue. You can see where they glued on some of these other caps. They got a nice fuse. Unfortunately, it's not a union fuse. It's a nice pop-out fuse, but it is a union. Let me get a picture of it there. Battery. Right there it is. Look at that. And it's soldered in. Ugh. So what we're going to do is going to have to replace that whole assembly and take that board off. And I got this beauty here. So this I think will go right in the same holes. Look at that. I go to DigiKey for my stuff. I think Shamazon, you're gonna get ripped off. This is the holder. DigiKey. You can see that. I'll put the part numbers in the link, but it's the right holder for a CR2450 battery. Here's a brand new, and I mean brand new battery. I had some batteries I ordered before when I was going to do this job like 5 years ago. I realized they're already dated 2015, I think. I'm like, they're already 10 years old. 2016, there you go. The lighting here is terrible. 2016. So I got a brand new one, and that expires in like 2031, so make sure you got a good battery. You have to be careful if you buy stuff from Shamazon. They'll sell you batteries that are already 10 years old. So I don't recommend going to that. They're okay for some stuff, but electronics, I'd stay away from them. And this battery, I checked it out. It's at 3.3. It's the same as that brand new one, but This synth I bought in like 86, 87 when it first came out. A little over $2,000, and it was worth every penny. I love it. But since I got it open and I have to fix the MIDI problem, I'm going to replace the battery. So I'm not sure which job I'm going to do first. Keep you posted, and I'll show you the trick. We needed to remove these boards. This board looks like 1, 2, 3 screws. Looks like I have to get the hood open a little bit more. And I got to remove these harnesses. 1, 2, 3, 4, 5 harnesses. That's not too bad. They look like they come out easy. And they don't have access. I'm pretty sure it's one of two parts. We talked about it earlier. It's either a 74 LS04, which is right there. You can't really see it. Or it's that transistor. So that's really all that's in the MIDI out. And I'll put a new section up as soon as I get that board out. I'll show you how to take it out. And I think I'll do that one first, because the battery, like I said, still at voltage. So what I can do is I can replace the bad part over here, not futz with the battery, so I don't have to worry about the program and all that, and then fire it up and see how it works after I just do that one step. Then if that goes good, we'll take this board out. 1, 2, 3, 4 screws. 1, 2. That harness down there is going to be a bear. 3 harness. 4. I don't like the flex tape. People are scared of that. 4 harnesses on that board. I might be able to just take the screws off, put something down here like an ESD pad, and you know, something like this. I got my strap on, but and lay the board on that, and then I don't have to do the harnesses. I can just remove it from this other board. It's like a daughter board here, and cut the leads. Don't desolder a hot lithium battery with a solder gun. Don't do it. They get pregnant, as we call it at work. And after they get pregnant, they can explode. So I'll take those 4 screws out, drop the board down without touching the flex tape. It's very sensitive. These I'm not worried about. These are great connectors. Just drop the board down, cut the 3 pins, desolder those pins, and then put in this bad boy, which should now hold the new 2450 CR2450 battery. That's what they need, CR2450. So that's it for now until I get the boards out. Okay. So I'm going to go into the jack board first. And when you're troubleshooting, the best thing to do is check all your power and grounds. So, CN4 is your power interface, and this is a beauty to work on. So the power interface comes over here to the power board, and the CN4 is the second set of connectors looking down. So let me get my ESD strap on. It's turned on right now. One more thing to note. You have to elevate JX-10, because when you open the hood, you want to turn it on. Look, you gotta have some gap there, see? So I put these 2x4s, built them before. I probably should put them on a different angle, but they're good for now. Allows you to open the hood, get in there, and CN4, like I said, there it is. Second one to the right. Everything's color coded. Everything's nicely labeled. Roland, I like it. You guys did a good job designing this. Been a design since '83, and this is impressive. It's a good board. Very good board. I love the camera doesn't have zoom, so bear with me. But I do use this stand because I've had so many people complain, your camera's moving around too much, I'm gonna get sick. Well, play more Descent. That's my answer. That'll teach you to deal with motion. Alright, I got this voltmeter. Binoculars on. We'll start checking it out. Black is ground. Isn't that nice? Unlike AC, I gotta be careful this thing falls. I don't want to hurt anything. So the first one is 15. Second one is minus 15 is blue. I like to use yellow, but whatever. Oop. I'm sorry. Looks like they did use yellow. And then 5 is purple, I think, and then the 7 is I forget where pin 1 is. Pin 1 is color coded. Nope. So we either got 7 volts on the outside edge, or we got 15 volts on the outside edge. And the ground is 1, 2, 3 down. That's one way to do it. Right, so top pin towards the back of the board. Ground. Make sure you use stuff like this. See, these are insulated. I know the lighting's not the best here. Alright, so we're going to go in, measure those points. You can do this live, or you can come back and don't fall. I'm going to turn it on right now, so be careful. And I usually tell people, young engineers, get your probes where you want them and then turn the power on. So, follow my own advice, I would do the same. But you can probably do the outside pins without too much risk. It's when they get close to each other, you don't want to short. And voltmeter's isolated, so I go down, pin 1. I go down to this end, should be 7 volts. It's 10. Got weird off the bat. I'm not sure what to use that for on the output board. I'll mark that down. Doesn't mean it's off, but next one up, that's the one I'm worried about because it's the one that runs the LSO4 inverter. That's off, that's why your Midi doesn't work. Second one is yellow. Should be 4.95, perfect. So that's not the reason why the board's not running right. 4.95 is plenty in spec. And the 7 volts is probably used for a display or something, so that's why it's 10 and that's why it's not critical. Let's go check the 2 analogs. This is a lot like a controller design. Very familiar with this. Outside 1, 15, get 14.9 plus. Next one, this one I have to be careful. I'm going to put that probe in first and then come in this side. Pin 2, minus 14.9. So, these are a little hot. Okay, heatsink there. I'm not sure how much power JX-10 dissipates. So far, voltages are cool. That is not the reason why that Midi channel out is not working right. That's too bad, because it would have been not easier, but it would have been quicker to just find a 5 volt supply problem and then debug the power supply. It's right there, boom. It's not the problem. So what we got to do now is go in to the jack board, Jackery board. That's that guy, van life guy. Let me grab this camera. Smooth transitions, jack board. There she is. So you can see the power supply interface I just debugged. Right there, it's the third one from the top left. Just debugged all that. There's no reason to think that the harness is bad. I mean, you could check it on this end of the harness too if you want to be super anal, but I don't think that's it. So that means getting down in there, put some light on the job, and debugging that LSO4, or even worse, that dropping transistor, what do you want to call it? Feed transistor. And a lot of MIDI boards don't have that transistor, they just have a pull-up. So, Roland, put a transistor there. So that's it for this point. I'm going to go and move my probes around. I will turn it off to move the probes, and then we'll start struggle shooting, that's what I like to call it, LSO4. That's what's in the JX-10. I duplicated it, the proto board. My output's weak. There's the proto board. I used a 4 oscillator package. I didn't have the one they used. So I used a 6-in 137, wired it up like that. So I got the output of the JX-10 going to these 2 points here of the proto board. I have them labeled. Midi pin 4, Midi pin 5. So, pin 4 goes to the low side of the let's see, Midi out of the opto. It's actually the high side. You can see the direction of the current flow. Pin 4. Here's pin 5. So you put 5 volts into that 220 ohm resistor. That's just current limiting for the opto. You don't want to cook the opto. And then it turns on. This would be inside your MIDI device. So I got 4.5 volts right here at the front end of that transistor. I'll show you that. Here's pin 4. Pin 4. It's the voltmeter. Nice beauty from Harbor Freight. Don't pay much to get these things. Look at 4.5 volts. So that's perfect. So that's good because this part is obsolete. I was going to replace it with a 2-in 2907, which is a P&P as well. See, it's a P&P, points in P&P. But I don't have to touch that part, which is good. Now we go over to the fun part. I think the problem is. Look at that. That is the top end of, this is the LSO4. Why they use an LSO4 is beyond me. 74 LSO4. Should have been an open collector. Because you're really working like you're an open collector. Because you got 5 volts coming out, same here. These are all LSO4s. 5 volts coming out here, and then that toggles high and low. So when it toggles high, it should have been an open collector, which looks like that. So you pull it up to 5 volts with a resistor. This would be inside that inverter. This is an LSO6. I don't know why ding dongs at Roland, they usually do a good job using LSO4. So when it opens, then it would have been pulled to 5 volts. Look at that, through that right there. Bam. Closes, it doesn't. That LSO4 should have been LSO6, but it's not. And I'm not changing it, because if I change it, then I have to put pull-ups here and here, and I don't want to add parts to the board. PIA. So as I said, you put a scope on it, you see a real narrow pulse. It's mostly high. This is what the MIDI signal looks like. I'd say it should be close to 5 volts. And when you hit keys and start sending serial data, this should be close to 0. Well, let's say up to 0.8 for logic levels. And this shouldn't be at 3 volts because that's below V input high of what your UART's looking for, because this output is not going to drive the opto in the next Midi device input stage, which looks like that. Okay, so that's why we got to figure out what happened to these. I'm going to change, they're all 4 in a pack. So, well, there's more than that actually, but yeah, whatever. 6 in a pack, it's a 14-pin device. So we'll check 5 volts, we'll check the ground, we'll check the signals here and here, and then we'll check the signals here and here. And I suspect that somewhere in this part, hopefully we have 5 volts. I checked the power supply already, it's fine. But if we have 5 volts here and the first stage is the bright logic levels, then this output stage has probably been compromised. It's funny, it does work into a Roland MKS-20. So the MKS-20, obviously, it's over here in my rack, can handle a lower level digital signal, but that's the only thing it works into. So it's kind of a pain in the ass because I have to take the output of this, plug it into the 20, and then take the output of the 20 and put it in all the other Midi devices, which is, it works, but it's a pain. So I want to fix this. And I want to change the battery. Talked about that already. Here's my new battery and my new battery holder from DigiKey. Use DigiKey. Don't buy anything from Amazon. They'll sell you batteries that are 10 years old and they'll call them brand new. So that is the part you need for the battery holder. And then before you put the battery in, check the expiration date, 2031. So that's a new battery. That's not a 10-year-old battery, but don't get it from Amazon. Get it from DigiKey or somebody reputable. You can buy some things from Amazon, but electronics is not one of them. I don't care if they don't like this because I can stuff it. So there we are. Next thing I'm going to do is put a logic probe clip onto the part. It sits on this board right there. And there's a transistor I don't want to replace because it's obsolete. And that board sits underneath. I'll show you in a minute. Alright, we got it opened up. Showed you that earlier. 3 screws on that side. 3 screws on this side. Oh, but there's 2 tricky screws. 1, 2 goes into here. So you get the 6 screws off. It's like, it's not budging. What do I do? I'll flip it over, take those 2 off. You can see my setup here so I can open it up without hurting things. A couple 2x4s. I do have it grounded to my ESD pad. It's winter here in Area 49. I got my wrist brace on. Yeah, this is my DJI camera. I love it. Another SLAM. So if you want a camera that doesn't overheat, don't buy the other guys. Get a DJI. I won't name the other guys. So we're going to put the voltmeter on that LSO4. Let's see if I can do this. Right. I got my ground. I could have grounded it over here, but got it grounded, single point ground. So dip clip, pin 1. Point that way. It's right there. There's the board. They call that the jack board for obvious reasons, because that's where all your jacks are. So I take the part off. I'm going to take the board right out of there. It's got 1, 2, 3, 4, 5 pretty robust connectors, 0.1 millimeter spacing. You can see those those will come on and off without too much concern. It's the flexi tape ones, like that one. But you gotta watch how flex tape will break. And once you break flex tape, you're kind of cooked. We've all done it. So this thing's off right now. Yep. I love how this thing is. This is like, Roland really knows their stuff. You really, really want to be purist about it. I would, well, why don't I do that? I'll probe at the chip. So there'll be no bullshit. We'll know exactly what voltage is what. That's too short. Here. Patience. People don't want to spend time with the YouTube doing this stuff, but you know what? This is what it takes. You gotta fiddle F with everything. You gotta find stuff. You gotta get the right parts. You gotta get the right probes. Right. See that? I don't have to show you that part because all these logic devices are the same. Pin 14 is always hot. Pin 7 is always ground. And in the DC world, ground is black. In the AC world, ground is hot. Made me crazy when I had to work on a house AC wiring. Like, why'd they make it backwards? Alright, so we're going to turn it on and make sure everything's okay. I don't have the Midi port plugged in right now. It doesn't really matter. We already know it's weak. Alright, there he goes. Look. It's 5 volts. Still works. I love it. It's like when you're working on your car and just pop the hood, let the engine run. Guys are genius. It's got hinges. It's unbelievable. That's what I always tell my new engineers. Don't move your probes while it's turned on. It's not worth it. You're just going to cook something. Because you're going to like touch two pins together. So I want to look at pin. I'm going to look at the output. Output's on pin 8. Nice. It's on the other. It's on this side. Perfect. Perfect. If I had a scope, I could put a scope on it, but yeah, we know what we're doing. Pin 8. What's pin 8 got on it? Turn it on. Oh look, 2.3 volts. That's because there's no 5 volts being run through my simulated opto isolator circuit that a normal keyboard would have. But again, that's not right. So let's go to pin 9 and 10. Turn it off. 6 works. Always check to make sure you're not freaking things up. 8. So 9 and 10 connected. Alright. It's on there nice. So I'm on pin 10. 10 is the same. So pin 10. Logic low. Makes sense. Because the logic low would be inverted, and that would be logic high. So if we go over to pin 11, it should be logic high. Alright, here we are. Voltmeter turned off and turned back on. I was looking at pin 11 of that LSO4 on the jack board, and it's nice logic high from the micro or the UART. You see it toggle a little low because I don't have a scope. I'm just so there's this waveform, mostly active high. That thing's supposed to invert it. It does invert it, but the output pin on pin 8 is only like 3 volts, 2 volts, which is not going to make the receiving Midi board happy because it's got to pull down an opto like that. This is what's in most receiving Midi boards, this opto isolator circuit. Nice that it's optically isolated. That means that that's ground on your receiving MIDI device is off a little from this ground, it's not gonna get ground loops. So these guys are clever. We do the same thing with space-based hardware. So I got to replace that device. No question about it. Where is it? It's hiding. There it is. Right there. I got the dip clip on it right now because I was probing it. But so I won't belabor you with pulling that apart. It looks like 1, 2, 3 screws. Hopefully those are the only ones that are in the middle of the board there. 1, 2, 3. Hopefully there's no surprise screws. Oh yeah, I gotta take off, not only that, but I gotta take off all the screws on the other side so the jack board comes out. Make a noise. Yeah, I gotta go in through these little crappy speakers. So that's the deal. I'll show you a video of it out, and I'll show a video of the... I'm going to use a dip socket. That way I don't have to desolder and pull the board if this happens again. If it burned out once, it's probably burn out again, because it's really not the right application. It should have been an LSO6. Put an LSO4, I don't know why. They have 2 spares. Everything's here. You could put pull up there, pull up there. That one has the pull up, as you can see, the through, and the output has the pull up. So can't use the through because I'm trying to use this board as a controller, so I have to use the out because I got, you know, 76 notes, splits, all kinds of nice stuff. It's a great controller board. There you go. That's it for now. Okay. Screws off the back. There's a Roland little cup. 1, 2, 3, 4, 5, 6. So you can see where they come through with the jacks. This is the jack board. 1, 2, 3, 4, 5, 6. So this big plate there. 2 screws in each edge. Then there's a little plate where the Midi jacks come through. And there's the program jack. There is a screw above it, but I think that screw, if you look carefully, that screw goes into the body of the synth and not into the jack board. So that's what I'm hoping. We'll find out. The 1, 2, 3, 4, 5 connectors are all removed. ESD strap on. Don't be silly. It's dry air here in the area 49 New England. So now I turn the camera back on for a second because I got to show you this. This is tricky. There's 1, 2, 3 screws, and the hood's open, but it's kind of like pulling plugs out of a Prius. You got to do more work. Take off all the washer assembly. Well, here I don't want to take this off, obviously, but what I'm going to do, you can use something like this. See this thing? Because you're not going to get a screwdriver in there. It's not much strength. And you can get at it. You can see if it's the right one. I love how they put ground straps on other little spots here. It's really cool. So this looks to me either that one or that one's a little smaller. That's probably a better one. Yeah, I'll use this smaller side. So let's try this one. So you can see what I'm trying to do. Put the camera down just a second. And you can push in with your left hand and try to rotate it. Good. Let's rotate it. Okay, so that's not too bad. Not in there too hard. Because we got to get that jack board freed up. You have to get to the back of it to take that part off. Like I said, when I go to put the new part on, I'm going to put on a 14-pin socket. This one's the toughest. Alright, it's turned. Okay, so they're all turned. So now you can get in there with a real... See, even a stubby screwdriver is not going to get in there. I know Craftsman kit has some really small ones, but I don't think they're going to do it either. So so I can keep going the way I was. There's a little teeny one here, but that's not going to go in there either. So, and another thing I've learned now, working on cars and motorcycles, one of these, boom. So you get the right head, smaller head. See? And then, will it work? Ooh, oh, so close. Well, so good. Oh. Never give up. Hold on. Look what I got. Ta-da! So, it's sort of like that other one, but it's just a little more. See, that should move it up and down or whatever. But you can keep going with the other thing. But let me get my strap. Strap. Oh, here it is. I don't take any chances. Get my EST strap on. You have EST shoes and smocks. Actually, I got an EST smock. Wouldn't be a bad idea. And the floor is where I work. So even if you're not strapped in, you're gonna. Gosh, I wish I had a little screwdriver. Almost like this. You're seeing this. Good to take the center screw off. They really didn't have much of a chance. Then you're going to want to not drop that screw, so instead of a magnet. This thing here. Yeah. Alright, as I said, get these little cups. Had these all labeled, pulling apart a laptop, but laptop got back together and it works. Yay! It's a lot harder than working on this thing. So there's one. Two. Get that magnet again. I really recommend getting a bunch of these little aluminum cups. It was a godsend when I did the laptop, because first time I did the laptop, I didn't really pay attention to what screws went where, and there's like 3 or 4 different micro screws, really small, and they're not interchangeable. I ended up with a couple leftovers. You listen to click and clack. It's a common problem when you work on a car. You get more parts when you finished than when you started. I'm going back to this thing. Yeah, this last one's going to be up there. Shoot. Do it first way I want to put it back. See that down there? Yikes. It's a harness in the way. I'm not touching that harness. Leave it there. Keyboard too well. I think they sell a screwdriver that has just a round thing on it. This probably was put on the case before they put the case onto the keyboard, but I'm not taking that off, because that means these harnesses are going to get all stressed. There's only 4 screws that goes with the hinge to the hood. I popped the hood on a JX-10. Who knew? Changing oil will be this easy. Yeah, I don't know if their other Roland products are as elegantly designed as this one. I mean, this is truly impressive. I got it in the, I'd say, mid-80s. I'm not sure when it came out. 85, I bought it in 86. Taking piano lessons and I wanted a fuller keyboard, but I loved since that's free. You can see the board starting to move. Take my little magnet out. Ta-da! Yeah, definitely magnet. Okay. Okay, you two fans and aliens. 3 screws. 3 screws hold the back of it. Hold the board to the base, and I'm pretty sure she's free. There's that one screw I was a little nervous about. There's a moment of truth right here. You guys get to witness it. Yep, look at that. Just carefully move that one harness. These are keyed, so don't worry about them. I'm pulling in right. Oh, there's some nice my tape. Alright, so I gotta go through. Oh, that's a ribbon. Yeah, we talked about ribbon. Look at it, it's a ribbon. It's a ribbon cable. Do not want to mess with ribbon cables. It looks like it's stuck right here. Oh goodness. Look at that. Yeah, that's the ribbon tape from way over there. Comes from the the memory card. Here, look at this. See, the ribbon tape goes down, 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 down into where you put your memory slot. So let's get data, address, chip select, kinds of peripheral functions. But you can see the problem is my last jack. I do not want to mess up this memory slot. Hanging up. It looks like the tape over time has gotten stuck to the and the other thing I learned, I did this to a watch of mine. Don't touch memory. Flex tape. Metallic objects. You cut them and you're cooked. So I gotta get something non-metallic I can push underneath here. That's not a sharp edge that could lift up. See how it's stuck? Right here. Right here's good. I can clear this board there. My last jack is hanging up. I don't want to cut. See, that carries all the buses, so there's probably like at least 32 connections. So I might turn the camera off and do this delicate operation. It's hanging up just a little bit. It's almost there. Hold on, let me snap this in. Still see it? I guess you can. Let's move the lights around a little bit for the patient. Okay. It's gotta come out. So there's no. I'm getting damn close. Alright. Alright. Okay, everybody watching this. What I put together, you can see me cry. Ta-da! So, the trick, if you're watching carefully, is you have to sort of manipulate this ribbon tape. Get this bad boy out. And there is the suspect part. It's a 74 LS. Looks like a Hitachi symbol on it. O4P. So what I plan to do, and you don't need to watch this on the video, is replace it. I wish I had a 54 because 54 is middle spec. I got a 74 LS. Don't worry about the P. P means plastic. And And we're going to use a see, it's in the bottom, that thing. That's a nice one. It's got, looks like it's got gold contacts. So I'll get it out of here. You don't have to watch that. I'm going to desolder that bad boy right there. Let's look for any sort of heat, thermal. I mean, a lot of times when you debug things, visual is your best helper. That and stare and compare are two things I adhere to as an engineer troubleshooting. And I don't see any evidence of any thermal, because it would take it would. There's a bit of a coating on here. It would the coating would get browned. So there's no evidence of that. So I'm gonna probably use wicking. I don't have a high-tech solder sucker. So you got three ways you can remove solder. One of these. Some of this. I prefer this method. Oops. Little thing on there. I know people at work love these things. But so you push it in, heat up the solder, and it pulls it off the part. And if you had to do a lot of work, you get one of those soldering irons. Like if I have to recap, I'll get that. Alright, I'll show you what it looks like after I put the socket on there. Didn't have to cut any legs. I know I have some techs who I work with. They love cutting all the legs off and then you can pull it apart. But if you want to do a failure analysis on it, you can't. So, I guess I was going to put a socket. I got one of all gold plated leads. And I cleaned it all up. There's a lot of flux on this board. Oh my god. Look at this crap. I mean, I think this is all flux. I'm not going to clean the whole thing up, but it's flux. So you want to make sure you inspect your solder joints. Doesn't hurt to use one of these bad boys. Make sure you don't have any cold solder joints. They all should be shiny. You should have 360 degrees around each pin. It's hard to tell with the camera, I know, but I did look for that. I haven't been trained in doing solder because I'm not a tech, I'm an engineer, but I know a lot from what the techs have taught me. So this is 74. It's a COTS. Like I said, I wish I had a 54, but those parts are obsolete too. So what I usually do, see what I'm doing here, is I take the legs, push the part slightly on the edge, because when they come, the legs are kind of like wah, and it won't go into that socket very good. I'm gonna strip on here. So just lightly take the part and just sort of push down across the whole body of the part. This thing is nice. I think Roland's got some fine electrical engineers. Pin 14, pin 1, it's all labeled, but you can see all the flux all over the other parts. So I've got that socket in there. Look at this. Don't push the pins in too far. Bam. So this part goes bad again. You saw what it was like to pull this board out. It's not easy. I just pull the part off the socket, put a new one in. Maybe I'll look for a 54 LS04. Like I said, I'd love to change the design to an open collector LS06, but I'd have to add a couple resistors and have to rework the board. You know, the blue wires and resistors and all that, and have to pull it up to 5 volts. So I got 5 volts on that pin, so I have, yeah, you can see the power bus right here. Look at that. Here's the power bus, pin 14. So usually they have the beefier buses are the power buses or grounds. This is only a 2-layer. Not even. I mean, this might just be. This might be a 1-layer board. Yeah, looks like it. That keeps their costs down, that's for sure. Oh, Roland. Jackboard. Lord knows if they can never buy one of these again. I don't know what the 0 means. But, jumpers. Not touching no jumpers. There's some caps. I was watching another video of a guy recapping the synth, and he was using one of these bad boys. Peak ESR, so effective series resistance, checks for leaky caps. So I guess it would be remiss if I didn't. 2, 3, 4, 5, 6, 7 caps. Usually you can figure out the footprint. Look, like this one's easy. So those tantalum caps that are electrolytics that are historical leakies. So you put these things on the analyzing 0.45 ohms and 104 microfarads. So you go look at it, see what it says it is. It says it's a 100 microfarads. Nice. So that's probably a good cap. There's another one. And it looks like it's a little tricky to figure out the footprint, but it looks like it's right here. That's not it. It's open circuit. We'll do that one. That one we did. That was the easy one. Let's do this one. It's next to a resistor. So there's a resistor. There is the cap. $107, so that's good. 0.42 ohms. It's not too leaky. Let's move over to this side of the board. 2, 3, 4, 5. Just do a couple more over here. Board's out. We gotta do the cap change out. Let's do it now. 107. Fine. Next one's right here. Oops. 105. I think these are all hundreds. There's 3 more to go. Looks like this one is maybe right there. That's the trickiest part about troubleshooting, is flipping it over and figuring out what it looks like on the back side. 46. We'll check the value in it in a second. 50. Well, could be. Put caps in parallel, you half it. No, it's 47 and it's 47, so those are good. Last one, tall skinny guy. It is. It's going this way. Boom, boom. $9.8. I think it's a tenner. So caps are, you know, not extremely accurate in terms of the tolerance, plus or minus microfarad, whatever percent error, but that little chip, and that's that transistor. I have a 2N2907, but 3 laws of engineering: keep it simple, stupid. Number 1 is, if it ain't broke, don't fix it. Number 2, keep it simple, stupid. That's actually number 3 too. So this is it's a piece of work. That's the program port for that. I got the programmer. I was smart enough to buy it when I bought the synth, because you can't get them now. So what we're going to do is put this board back in. You need to watch that. I'm sure it's going to be tricky. And I'll put that prototype circuit I built that looks like a input of a Midi, and see how it works. If it doesn't, then it's that part, which maybe I can test it without screwing it all in, but I don't want to do that, because look at the ground here and here and here. You got a good chance, if you don't have it properly grounded, it, you know, you'll make a mess of things. Back in the ESD bag. Like I said, it's New England, it's winter, it's high static electricity time. So this thing, you can get this off of Amazon. It doesn't work great. It's okay. Turns off really quickly. Comes with a couple of more dingleberry type probes with the clips, but I find these are easy. But it would be nice if it had nice pointy probes. But, so I'm not recommending that yet. I don't get any kickback for any recommendations anyway, so just trying to help out other owners of JX-10s that have this problem. Cheers. Okay. Board is in. A little tricky. Take a look at things. These harnesses go behind it. This is really tight in here. And I don't want to mess that flex tape up, believe me. You have to fish it under that flex tape. So what I did is I put 2 center screws on there, and I mounted this screw, and then I mounted that screw, and then that screw is the hardest. And then I put the screws through the Midi plate and then the left of the 1/4" jacks. So that's the sequence. Got my wrist strap on again. It's awful dry and cold here in New England. So yeah, I had to look at a picture. It looks obvious, but these are routed behind. So as I said, these are keyed. So just push them in, make sure everything's turned off. Left it plugged in because I want to make sure it's grounded, but I turned off. So all the screws are in. Push these back home. Just press fit. See my new also 4 in there. I'll take a close look at that maybe. A little better light. There she is. It's Glory on a nice dip carrier. In case it happens again. What you do in avionics is put things called zeners and transorbs on the outputs. And what you do is you set a zener or a transorb up to protect for transients above 7 volts, let's say, because the logic device is powered by 5 and it sees above 7. It's usually enough to cause a problem. So if you had an ESD strike or something, I plugged it into another synth or whatever, it was dry or sparky, that probably would took it out. So that's in. Harnesses you just saw me plug in. They're in. These harnesses go behind. Just make sure all the other harnesses didn't get moved. This encoder I heard is really expensive and hard to get, so don't mess that up. Alright, so I'm about to do a power functional. I want to make sure that these screws that are on the circuit board are tight enough. I had to use this thing. Push the little screw on the end of it. Hold it with your 2 fingers without dropping the screw off and push it into that hole. That left screw was a bear. And then you need one of these to take the smaller one to finish pushing it, screwing it down. See, you can see there's just no, despite how good a job they did, there's no way to get the screwdriver in there. Yeah, that's all the way. These things establish the ground. If you look at the back plane, so you want to make sure that those screws are all snug. See a good low impedance ground path. Bond joints. We like to have a 2.5 milliohm bond joint when you get in that, but it's probably under an ohm. You could ohm it out. If you want to real. In fact, that's what we do when we build things, is we look at all the, this one is a little more snug. Not too tight. I'm a little kinked in the harness there. Couldn't help it. It's glued. Show you. It's glued to this board here, the back of the synth. But you got a tuck jack board underneath it. Like I said, it goes to your memory cartridge, which is critical. Especially if you go and you change the battery next and you zero out the local memory. I think I'm going to try as a separate video, but I'll jumper in a separate battery before I take this one out. And if I can just unscrew these screws and lay this board down so I can get at the solder, I can do that. If I have to pull these harnesses off, jumper in an extra battery is going to be useless. It's not going to help you any. Look at how these things are all pushed down by this harness. Ugh. Right here. That's pretty pretty scary. That's how it looks. I didn't do that. And some of these parts, we call that skylining when you have boards that are in multiple dimensions. You can see a couple caps here got tweaked by this harness when it comes laying down. And then this harness hopefully lays nicely. But you can see what it does. There is some collateral damage to these parts when the harnesses get snug. But they did a good job. I'm not complaining. It almost looks like they put some sort of a coating on this. I don't know, maybe praline. We saw that on the back of that board when I was soldering. It keeps things from getting shorted against these contacts. Alright, good for now. I'm going to close it up and see how it works. Turn it on. So there we are. Get a good logic level out of the LSO4 I replaced. It's 3.7. And another interesting thing is this pass transistor is actually closer to 5 volts now. I think that gate was loading that down. The transistor, the pass transistor that turns on as soon as you turn the synth on. And it's still working. So that's always good. Take it apart, put it together, no extra bolts, and it still works. So I can check it in the rack and see how that works. Thanks. The truth, I have the output connected up to my other Midi devices. Got it over here on this beast, on the core wave station, and comes into the Sapporo. It's a nice device out of Italy, and it allows you to use various controllers and set up various patches, and it's just lets you go without a computer if you want to do complex things. As you can see, that's the JX-10 acting like a controller again. Yay! And I think if you look closely at the Sapporo top line underneath, let's try to get this better. Better image of this thing. Oh, that's coming out or not. It's kind of hard to see. Yeah, that really focuses in very good. Sorry, folks. Let's try the. It is working, so it's awesome. Our fix. WaveStation's got a nice feature. It's got this MIDI status. It gives you all this channels on 16 channels. Protocol. And if we're lucky, we'll see some toggling on channel. I think I'm coming in on channel 1. I got this MIDI board split. But that's working. So awesome. New LSO4 did the trick. Now, next, I'll do a second chapter for the battery because this is going to take it was kind of long to replace that part. But now that the cover's open and the hood's up, we'll do the battery while we're in here. So, thanks everyone. Good luck with your JX-10s.